So I'll be presenting some of the learnings that we had during the Smart Manufacturing Forum held in Taiwan. So the title is, and I just would like to connect it to additive manufacturing. So did you know that additive manufacturing is, what they call this, is opposite of something that we know in mathematics? So when we add, we get the sum, but for additive manufacturing, we get the product. So it's a kind of, yeah, we can think about this. In 1784, we have the Industry 1.0, which constitutes the mechanization of the production system. And for the Industry 2.0 is the electrification, and for Industry 3.0, we have the automation, and now we are towards the Industry 4.0, which is cyber-physical and interconnectivity of this information and machines. So what is smart manufacturing? So there are these technologies of Industry 4.0 like Internet of Things, cybersecurity, augmented reality, big data analytics, and so on, including additive manufacturing. And when we incorporate this into production system and make use of data that we generate and gather to optimize or optimize the production system, we go to smart manufacturing. So we heard this other application in smart buildings and cities, smart grid, smart warehousing, and the smart factory. So here, I'm showing you is a smart factory, example of a smart factory. So for the smart factory, we have the machine-human interface, we have the communication system, we also have the wireless and wired communication system, we have sensors, augmented reality, and automation. Now for this type of system, we have the communication between machines, communication between human machines, machines to human. So for machine-to-machine communication we can do with the wireless Bluetooth or 2G, 3G network. But for human to machine or machine to human, we may need a 5G network, which is faster, because sometimes for human to get the status of the machine processing, we need a visual or videos like that on a remote area. So we needed a passive connection for this one. And that goes with the augmented reality, so we can have the idea on how these things work. So here, you can see here in this slide some of the component of the additive or smart manufacturing. So we have the computers, the communication systems, and automation. So this is not the advertising, so we don't have sponsors for this one, but I put some of these suppliers that we have for smart manufacturing. Okay, so I've shown earlier that we have the for smart manufacturing, we collect a lot of data. So we have installed several sensors like temperature, humidity, and everything. And we need to collect this data at certain intervals of time. So maybe every second, every minute. So we generate large volume of data. So that would amount to terabytes to exabytes of existing data to process. And depending on the amount or the frequency of monitoring, we have the velocity. This indicates the velocity. And there are also different variety of data. Now, some of these data are maybe useful, or maybe we're not sure, or we can use in our manufacturing. So we need to process this data to do the right things at the right, or to achieve our goal of manufacturing and do something at the right time and the right thing. So for simulation, role of simulation on additive manufacturing. So this is a critical part of the additive manufacturing. So if, for example, we have design, then we print it, And sometimes there's a problem in the design, we print it again. Maybe we can minimize this cycle of printing and print the drawings right the first time. So we use the trial and error, we reduce the discrepancies between drawings and printed items. We have faster optimization through, they call this digital twin. So we try to imitate the actual production system in a digital way to speed up the process of optimization. And we have to optimize the process condition, printing direction, support material build plate requirement, and other parameters. So for the smart manufacturing and additive manufacturing, so we just made this comparison on my own based on these characteristics and of the smart manufacturing and additive manufacturing. For smart manufacturing, in a conventional way, we have these several processes that we need to monitor, to collect the data and do some actions to make everything optimized. So, for example, for smart manufacturing, we have the mass production, we need a smart labor, and robotics, and also automation. We have both of them can be used for mass customization, interconnectivity, real-time monitoring, and lean manufacturing. So both of these type of additive manufacturing, smart manufacturing, gears towards lean manufacturing, which is to lessen the inventory. So for additive manufacturing, we try to lessen the inventory or the difference between the supply and the demand of the raw materials. Yeah, for additive manufacturing, we try to go away some of the processes. Then maybe we can make the monitoring simpler compared to conventional manufacturing using smart manufacturing system. So here, you can, as shown here, we have several processes for conventional manufacturing. If we convert this to smart manufacturing, so we have several monitoring stations for this several process. But for additive manufacturing, we can only have monitoring on these two processes as exemplified in this slide. So it makes smart manufacturing simpler. Yeah, so another thing that we should consider is the impact of additive manufacturing on the supply chain. So we try to lessen the inventory of raw materials by having one kind of material only used for 3D printing. So we have we eliminate the long lead times, high transport costs, high labor costs, and remote factories. So we can have remote factories for additive manufacturing. So yeah, that's and we have the factories closer to customers, and we can print the product on demand, like the services of 3D to go and the Shape Cloud. Yeah, and another thing for the possibility or the what do you call this? The adoption of additive manufacturing, smart manufacturing, we try to do with the multi-materials 3D printing. And there's this new file that being developed by the ISO and ASTM on the AMF Data Format. As presented by earlier, we have the STL file as standard format for additive manufacturing. Now for the ISO ASTM standard, they are developing this AMF Data Format. So for this one, it has a support for materials, color, lattices, and constellation, and we have metadata for additional information including authorship, special instruction, and copyright information. So this is similar to PDF file, and we have the we use the XML-based format language. And another thing, as depicted in this figure, so similar to STL, we have the triangulation or the tessellation pattern. But for the AMF, we can curve this triangle, so we can increase the resolution of our printed materials or the file without making the file very large. And we have this icon for this type of data format. Okay, so for this for the adoption of 3D printing for smart manufacturing, we need to have our 3D printers interconnected. We can put more sensors on it to monitor the printing process and optimize the printing process. At the same time, we can also include some artificial intelligence to make the process optimize on its own. And we need also to have multiple materials 3D printing. So imagine we can also print circuit boards, some ICs. So that would be nice if we can print a computer, or we can have a printer that could print a printer. So we can have self-replicating printers. So if we can do that everything in one printer, then it's we can modify or the benefits of additive manufacturing. But there are some issues like regarding data security, ethics and copyright, recycling and end of life of printed products, and product standard for various applications. So that's why with this project that we have at ITDI, we are also involving the Bureau of Philippines Standards to form a committee to establish standards for additive manufacturing. And another thing is that maybe we can think about how 3D printing or additive manufacturing can enter into a circular economy type of supply. So we can supply the printers or in a circular economy or the printed products. So maybe we can think of this thing that we could recycle part of the printers or these printed products for reuse on the other applications. And just some last comments regarding the AMF format. Basically, this is a text file that can be zipped, and because of that, maybe we cannot do some restriction on printing and access like the other file formats that we have. So maybe we can include that in the future of the development of this data format. So for now, that's it for the application of additive manufacturing or for the smart manufacturing of the industry in the Philippines. Thank you very much.